right, chapter 4, we're getting into quantitative data. This is where it begins to change. Don't get lulled into a false sense of security with how easy categorical data seemed to be. It was easy. There's not a lot of detail to it. It was what's the largest, what's the least, creating the bar charts and pie charts. You're talking about percentages or counts, and that's about it. Quantitative data says that I've got data that can be computed, that can be manipulated, that can be worked with. And we can talk about that. We can crunch numbers. We can find means and medians. We can find modes and standard deviations and IQRs and all of these things, which in the past, in chapter 3, wasn't really something that we needed to do. And so pay attention. We're going to introduce some graphs today. Really, we're going to focus on 4 graphs that we're going to be dealing with. We're going to be creating these and interpreting these graphs as we build them. So let's kind of set the stage. Number one, anytime that you have a variable that can be worked with, a number that can be crunched, if the mean makes sense, if I can calculate the average and that makes sense, then you've got a quantitative set of data. Be careful. Don't get into the idea that you think that if it's a number, then that's quantitative, right? Football jerseys obviously aren't quantitative data. That's a categorical data. It's a name. It's simply another way of identifying something. So be careful. Don't get too locked into that one thing. The 4 that we're going to talk about, it's really we're just going to talk about 3, but we'll mention the time plot. Histograms, stimuli plots, and dot plots are going to be the things that we tend to focus on. Time plots we'll talk about. We won't really make these. It's more reading them and interpreting them. This is where you see those a lot in the stock markets, so we'll get to that in a minute. One of the most useful graphs is the histogram. The histogram you can see here. A question was asked was, how many hours on average do you spend watching television in a day, right? And here you have a number of people said between 0 all the way up to say 13 hours a day on average. That's just crazy. If I look at the histogram, number 1, I'm looking for a title. I'm looking for a number line on the x-axis. This part down here, that is the essential difference between a bar chart and a histogram. A histogram has a number line. Those bars were placed there because of the number value they are. You can't rearrange them. And the height of the bar, just like in a bar chart, is frequency or relative frequency if you're using percentages. But the distance between the bars means something. If there's a space in between, it means that for that space, that X value, there was 0 data. In a bar chart, we always tried to space out the bars. That didn't have any significance. In this case, you're on a number line. So when there's a gap, which is something I would want to comment on, then there's something about that said there was no data in that group. Here, one of the questions they asked is, what's the most common response? So this is easy. It's which the highest bar. In this case, it's 2. In this case, this is what percentage of people watched no more than 2 hours a week? This is a little bit of a challenge. We'll have to estimate a little bit. Here, they're giving you the height of the bars you can see in the picture are essentially the percentage. Over here, it tells us the vertical axis is a percentage. And so this is a relative frequency histogram. If I wanted to find out what percent of people watched no more than 2, right? So no more than 2 would be 0, 1, and 2. And if I were to add that up, we could say this is about 25 plus 22.5 plus that. So we're looking at somewhere in the neighborhood of 50%. Give or take 3%. I'm not really sure. But we can add those up, and that would tell me that at least 50%, or around 50% of the people watch no more than 2 hours a week. When you create your histogram, there's no right way to do the bins, right? The width of your bar is called a bin width or class width. In this case, they did 1 hour widths. It made sense. It gave you a lot of bars. Tends to be up to you to decide. However, let me give you some guidelines. If you're going to be creating a histogram, I would recommend deciding your bin widths, your class widths, to be somewhere between where you get 5 to 10 bars. If you have less than 5 bars, a lot of the time it means your bins are so wide you don't have as much detail. But if I have so much detail in my bins are super narrow, it means that I'm going to have a lot of data. In this case, going 1 hour wasn't bad. It was definitely easy to do that. Okay, but in this case, when I'm doing this by myself and I'm trying to decide how many bars to have, I'm trying to get 5 to 10 bars. That's a good guideline. If it's 4 or if it's 11 and it still looks good, it's fine. It's great. Don't stress about it. Okay, remember, label the x-axis here. This should have hours spent watching TV. I think that the title here should be down at the bottom, hours. And then on the side here, this one gives it on the right side. It's much easier to put the title of the axes over here. Right, so title, label your axes, and of course make sure that the bars are the correct height and there's not too many or too few. The next graph is going to be what we call a stem and leaf plot. A lot of this, you've seen this before. I've already taken some data, and this is the population change over a course of time in the United States. And so here we have in order already. That's really nice to be able to do. By the way, you can do that in your calculator. Sort ascending is one of the features, or descending is one of the features in your stat menu. If we look at this and we create a stem and leaf plot, we're going to go ahead and we're going to create the division between the stems and the leaves. When we do that, I look at the tens place. Okay, so essentially there's the last digit gets to be the leaf. I don't care how many numbers you have, whatever the last digit is, that's what's going to get to be the leaf. In this case, we're dealing with numbers between 0 and 99. So we're looking at most 2 digits. And so you can see here that we have values from all the way down to 1 all the way up to 66. Notice my stems. Now this goes from the largest number down to the smallest. You could have reversed that and went 0 to 6 at the bottom. Those are both fine. In this case, they decided to start at 0 at the bottom and go up to 6. Notice that there's no 50 mark here. However, I have a 5. Because we have a 5, that's going to tell me there's a gap here. I need to do that. I cannot skip that. If you skip over it, you're going to be creating a misleading graph, and it's going to look like some data is closer together than it really is. So whenever you go up, whatever you start on, you have to continue that process until you get to the very last data entry. And so if we were to go ahead and populate this stem and leaf plot, it would look like this. Right? So over here you can see 6 would mean 66. I can see down here at the bottom 0, 1, 0, 6, 0, 9, 0, 9, 0, 9. So there's 3 9s in this group. You can see those right here. It's easy to create your graph once it's put in order because you can simply go down the list and add those numbers directly to your plot without having to kind of skip around and mark them off to make sure I didn't miss anything. A lot of the times you can find means and medians using a stem and leaf plot by marking off values above and below these things. And so remember this, that the smallest numbers always get closest to the stem, and you count outward. Right? And this is going to make sense in a minute because we're going to do something a little bit different. We're going to create a back-to-back stem plot, and everything on the left side is going to go backwards from what we've just talked about. So remember, your stems go here, and then your leaves go off to the outside. Now, in this example, we're going to be comparing the southwest states to the north and eastern states. And so if we go ahead, we're going to create another stem and leaf plot, but just on the other side. We're going to use the same stems, but we're going to mirror the leaves to the other side. Notice the smaller numbers are inside, and it counts out to the outside. In this case, this number represents 41, not 14. This is 43, 43. You can't see this original data, but that's what it would be. So the largest percent in the New England states, the Northeast and Midwest, you have is 62%, and the bottom one would be also 1%, 3%, 5%, 6%, no 10s at all, and so forth. When I'm asked to compare this, I can look at these and I can say, on average, or for the most part, it looks like there was more growth in the new Northeast states and the Midwestern states because the center, the main peak of this graph, tended to be up here in the 30s, maybe even into the 40s, when the South and Western states were down into the 10s and 20s. So you can compare what we would consider center, mean, median, mode, that kind of thing, which we'll talk about that later when I'm looking at back-to-back stem plots. The purpose of that is to compare different distributions. One of the negatives about the stem and leaf plot is that if I had, and this is a fairly decent size, this is not a huge set of data, but you could see really quickly that if I had 100, 200, 300, 1,000 points of data, that putting it on this chart would be an absolute nightmare. However, with the histogram, that's not a problem because you can adjust those heights. I could go on the x-axis or the y-axis by 10s, 20s, hundreds, thousands even, right? It's whatever I want it to be. In this case, I'm going up by 10s, so it's not a big deal. So try not to get data that is really spread out or that has large amounts of data to go into these stem and leaf plots. The next graph is probably one of the easiest and quickest graphs to create. So here you see from 1944 to 2000, you have the number of hurricanes that occurred in each year. And so we have a fairly large set of data. But when I create a dot plot, the first thing we do is we're going to create a number line on the bottom. We're going to label the number line, right? Because each value on that number line needs to be equally spaced out. If I had decimal values here or kind of unusual numbers that weren't so equally spread out, the dot plot might not be a good choice for your graphs. But these are all relatively close together, and there isn't a crazy amount of data. This is probably upwards of as many dots as I would want to put on a chart, but it turns out to be pretty good. I could probably make this easier with a histogram with that many data points, but I get the same kind of result. You can see here that the majority of the time there's around 2 hurricanes per season, and it's kind of going off to the side, off to the right side, which we call skewed right. Dot plot, here again, put your number line down first, and then go ahead and add a dot for each value. If, just like with the stem and leaf plot, you can't skip around. If you start going up by ones, then you have to continue going up by ones, and that's going to be dictated to you by what the numbers look like, right? So if I had 5, 10, 15, 20, 21, for most of them I could get by going by 5s, but that 21 makes me go up by 20s. So I'm going to have to go up, starting at 5, and count by 1s all the way to 21, and I can't skip anything. So that would tend to be a little bit of a challenge. I could kind of get around it. If that's the only one, I could put a dot just beside the 20 and just leave space in between all of my 5s to kind of imply there's 5 steps in between them. There's nothing that's kind of set in stone. Just make sure that your graph represents the data effectively and clearly. Okay, last one, this is what we call a time plot. This is where you see a lot of the times if you ever follow stocks or look at the stock market or any kind of market accounts or things like that, you're going to notice that you have a time plot, right? It tracks that value of the stock over time. Here you have time on the x-axis, and we have the value of the stock on the y-axis. So this could be interpreted as a 2-variable plot when everything else is only 1 variable, right? You got the variable at the bottom, and you have the height, which is just frequency. In this case, we have time on the bottom rather than frequency, and then the vertical axis is the value of the stock at the time. And here you can see we talk about trends when you are looking at changes over time. In this case, you can see for the most part with RIM, which is BlackBerry, and Apple, they tended to have an increasing or a positive association from a positive trend after 2008. Microsoft tended to be very consistent. It kind of, it's up and down, but it's kind of staying all at the same height. So you'd say it's a consistent trend over that particular time. For this graph, the only thing I really want you to be able to do is to look at the graph and interpret it, read it, know what you're looking at. We really don't spend a whole lot of time making these graphs. And that's the end of that section, right? I'm going to give you some assignments in the next little section. Make sure you take time and build these graphs by hand. I know that we've got lots of technology that can do this for you, but for the most part, you're going to be building these graphs with paper pencil, right? So take some time Make sure they're neat and clear, and you've got all the elements that you need. Hope this helps. We'll see you next time.